Okay, welcome to my channel. What I plan on doing today is to share with you a project that I worked on over the last few days. The idea being to make an environmental dashboard. This will use two D1Minis and a Raspberry Pi. The D1Mini is one D1Mini is connected to a Mqtt, an environmental sensor that measures temperature, humidity and pressure. The other D1Mini is connected to a Nextion display to show graphically the temperature in real time. The Raspberry Pi has a Docker container with a number of different services that will allow both the MQTT messages that are being sent to be routed, to be the logic in Node-RED, the real-time data being stored in InfluxDB, as well as graphs to be shown in Grafana. This is a little bit more of a detailed view of the sensor node as well as the display node, and this is the Docker container having a Mqtt broker, Node-RED. It has a MQTT InfluxDB bridge which takes the MQTT messages and converts them into database records. It creates measurements that are then stored in the InfluxDB. This can be then shown on Grafana with graphs and charts. Portainer is used to actually give you a visual indication of what is going on inside of the Docker container. This is what the actual setup looks like. These are the two D1Minis. This is a Mqtt. This is a Nextion display. And this is the Raspberry Pi running the Docker container, the Raspberry Pi 3. Alright. What you have, okay, this whole project makes use of ESP Home. Well, this project on the D1Minis are programmed using ESP Home. ESP Home allows you to take a bunch of components that are then written into a YAML file. The YAML file is then compiled into an executable that is then flashed to the D1Mini. We'll make use of a sensor component, for instance, like the Mqtt. You can see the entries that are going, that you would put in the YAML file. They would define what the different sensor measurements are. If you go back and we go to the display component, you'll see now the Nextion display is the other one. This allows you to control all kinds of info, how you display the messages, where they're displayed. If you have a look, the actual Visual Studio Code, these are the two projects. So there's sensor Mqtt and your display Nextion. This is the YAML file for the sensor, the Mqtt sensor. You can see you have different sections where you set up the name of it, the platform, as well as the Wi-Fi password, the IP address, which you can fix. You then can set up a web server, and then this is the MQTT broker, and then these are define the hardware, which pins the I2C is connected to, as well as the actual sensor values that are going to be sent out. The same applies to the Nextion. If you look at that display, the YAML file, it also uses the same platform, different IP address, serves up a web port, connects to the MQTT broker, but in this case it's an RX and a TX pin that talk to the Nextion display. You then have a number of text sensors which allow you to send the temperature reading, the humidity reading, the pressure reading, and the display will update that every second, as well as it gets the time from the SNTP time, from internet time. Then each of these values then gets written to you in the Nextion editor. When you create the graphics for the display, these values are linked. What I'll do, I'm just giving a brief rundown of how the whole system works, but what I'll do is I'll go in detail into each one of these components, how they work. These are the web servers for the sensor, the BME web server. So this shows you, sitting at that IP address, it shows you the temperature, the pressure, the humidity. And same for the Nextion display. As those details are sent into the display, these are the real-time values. On the Raspberry Pi, this is the Portainer. Portainer shows you these are the services that are running inside the Docker container. You can see here you have the Mqtt broker, you have Node-RED, you have the Mqtt InfluxDB bridge, you have Grafana and InfluxDB. Node-RED, this is what Node-RED looks like. It now has these flows that will take the MQTT messages coming from the BME sensor, will send one to the bridge, the InfluxDB bridge, and the other, and also to the display to update it in real time. What's nice about Node-RED is you could actually create complex flows and control all the logic of what you want to happen in. Okay, this here are some of the tools that you can use on the Raspberry Pi side. This is PuTTY, so this allows you to SSH into the Raspberry Pi. In this case I'm running HTOP, so I can actually see what the cores are doing, what processes are running. What I also have here in the background is a Winscp, which again allows you to copy files from my local hard drive across into the Raspberry Pi. These are the Docker files that control the Docker container. One of the other tools that I use is this Mqtt Explorer. So you can actually see here those MQTT messages that are being sent from the BME sensor. You can see there's temperature, you can actually see the historic value of how the temperature is changing. Same with humidity, same with pressure, the same with humidity. And then these are the updates that get sent to the Nextion display, as well as to the InfluxDB. Another tool that is very useful is this time series admin. This now allows you to look into you can see this is looking into the port of the InfluxDB server. You can tell it username, password, as well as the database, and then you can run queries. So if, for instance, here select from temperature, just only do 20 readings. If I run the query, you can see these are the 20 values here. You can see InfluxDB has values and tags and stuff. So this is the value, this is the tag. You can see that it's a BME 280. And obviously when you get into Grafana allows you to filter on the device. You can select date ranges like any database would give you that. This is now Grafana that is now showing the real-time data from the temperature, pressure and humidity, both in a chart form as well as in a dashboard form. Okay, as I said, this is an introduction to what I plan on doing. I will make videos after this in the next few days of each of the sections, how I wired up the sensors, how I wrote the code, and so I will post that on a regular basis, the whole project. Anyway, if you like it, otherwise subscribe so that you can get further updates as I post videos. Thanks for watching.